Step 4, exploring data. We've already read in the dataset into R and we have completed the data cleaning step, and the next thing we want to do is we want to look at each of the variables contained in our dataset and investigate the distribution of these variables. And what we will do in this section on descriptive analysis here is look at the univariate distributions of metric variables. How could we visualize them, and how could we have a look at how are these 20 travel motive variables distributed. So first we look at a histogram. We will be using the histogram implementation available in the package Lattice. So we have to load the package so we get access to this function. Lattice is a recommended package, so it should be available on your computer, and the function for creating histogram in that package is called histogram. We are not using the function hist, which is available in the base distribution of R for creating histograms, because later on when we are doing the profiling of segments, the function available in package Lattice will be more useful because it will allow us to condition on segment membership and will get conditioning plots. The histogram function in Lattice has a formula interface. So first we specify for which variable do we want to have the histogram created with tilde age, and then we have the data argument which specifies from which data frame should the variable age be taken. So we create the histogram. On the x-axis is the variable age, so we see the data range. What are the observed values for age? So we know the youngest was 18 years old, the oldest was 105 years old, and we see that the histogram was created by binning the data, and by default a certain bin width is selected, and for each bin the height indicates the percentage of total observations falling into the bin. So we know here this bin contains the most observations, and this looks like only containing a single observation. These histograms are exploratory analysis tools, and we'll need to normally use different bin width to get a feeling of what is a good representation for our data set, what does the distribution really look like. And what we want to do here now is use a more fine-grained version, so we increase the number of breaks, and what we also want to do is we want to change the type. We don't want to have percentage of total on the y-axis, but we want to have the density. So we execute this, so we now have a more fine-grained picture. Density here on the y-axis means that we've rescaled the height of the bins in a way such that the area covered by these rectangles is 1, and which means that the histogram is a density estimate, and we could overlay it with the density of some parametric distribution to see how much they would align, for example. An alternative way for visualizing what the distribution of a metric variable looks like is to use a box plot, and a box plot visualizes the 5 number summary. So it visualizes the min, first quartile, median, third quartile, and maximum. And we use the function boxplot for getting a box plot for the variable age. We set horizontal equals true, which means we want to have a horizontal and not a vertical box plot, and we want to have the x-axis labeled with age. This is our horizontal box plot. The box goes from the first quartile until the third quartile, which means the lower end is 32 and it goes to 57, and 50% of the observations fall within the box. The thick black line here is the median, and then we have the whiskers extending out of the box. Here the whisker goes down to the minimum, 18, and here the whisker goes out at most 1.5 times the box length. This has been selected because if the data would be normally distributed, it's very unlikely that observations fall out of or go further away than 1.5 times the box length. So this goes out up to the largest value being smaller, 1.5 times the box length, and points which are further away are indicated by dots and are so-called outliers. Now we want to look at the vacation motifs, which are in columns 13 until 32, and we want to get the percentage of yeses contained in there. So we look at which values are equal to yes, and then we take the column averages at the proportion of 1 yeses contained in each of the columns. We multiply it by 100 to get the percentages. So yes is now a vector containing for each travel motive the percentage of agreement, and we use the function dot chart to plot the sorted. We sort by decreasing equals false, so in increasing order, and we put on the x-axis the label percent yes, and we ensure that the limits of the x-axis go from 0 to 100, which is the possible range. So we create that dot chart, we zoom in to make it bigger, and we see that the variable with the highest agreement level is rest and relax with more than 80%. Realize creativity has the lowest agreement levels, but we have a number of motives which have sort of an average agreement level, and this is good news if we want to use that travel motive dataset for segmentation, because there seems to be some heterogeneity present in the dataset.